Alright, so after going over the length of part of the graph, which is arc length, today I want to go over 8.2, which is area of a surface of revolution. So basically, if you recall in sections 6.2 and 6.3, we talked about surfaces of revolution. If, say, we take a horizontal line and revolve it around the x-axis or the y-axis, we know how to find volumes of solids, let alone cylinders. Now, if we cut that cylinder and unfold it, we get just like a two-dimensional figure. And in the case of a cylinder, if that's the radius, and we cut it here and unfold it, we get the height and then the circumference of the bottom, which is 2 pi r, and the area, the surface area, is going to be 2 pi r h. That's if we have a known figure. What if we're taking any y equals f of x and rotating it? How do we find the area of the lateral surface? We can't. Not yet, so we're going to learn that today. So the definition, let f be a smooth curve, smooth non-negative. Remember, a smooth curve is a function that's differentiable and whose derivative is continuous over a closed interval over E. The area S of the surface that is obtained by revolving the graph of f over AB. First, if we're revolving about the x-axis, it's given by, so that surface area is given by S for surface area, 2 pi from A to B, y or f of x. It doesn't matter. You can use y, you can use f of x, square root of 1 plus f prime of x square dx, where f prime of x, you can also use dy by dx or y prime. Okay, and that's if y equals f of x. Okay, what if x is isolated? Now, if x is g of y, then the formula is going to change. 2 pi integral from a to b y square root of 1 plus dx by dy, or g prime of y square dy. Okay, so two different formulas for revolving about the x-axis. Now, what if we're revolving about the y-axis? And the proof is very similar to what I proved in point 1, what I proved the formula for the arc length using Riemann sums. Okay, same concept. So if we revolve out the y-axis, so you're always going to look for which revolution we're doing is given by. So it would be 2 pi integral a to b. By the way, this is c to d. It doesn't have to be the same values. Okay, we use different letters. So instead of y, we have x square root of 1 plus f prime of x square dx. That's if y equals f of x. So y prime is f prime of x or dy by dx. Now, if x is isolated, then the formula is going to be slightly different. 2 pi, instead of x being between a and b, y is between c and d, x square root of 1 plus dx by dy square dy. So we're going to keep these handy because we're going to go over a lot of examples to clarify them. So the first couple of examples are not from the book, so I'm going to write them down for you. Find the area of the surface that is formed by revolving the graph of y equals 2 root x over the interval from 4 to 9 about the x-axis. So right away, to know which formula I should use, first of all, I know it's revolution about the x-axis. So I start there. Now, is it y equal f of x, or is it x equal f of y? X equals g of y, or y equals f of x? Obviously, it's y equals f of x, so it's that formula. So let me write it down. 2 pi from a to b y square root 1 plus f prime of x square dx. So 2 pi a b, a is 4, b is 9, y is 2 root x square root of 1 plus f prime of x is 1 over root x squared dx. If you find the derivative of 2 root x, it's 1 over root x. So it's 2 pi, which is times the 2, it's 4 pi, 4 to 9, root x square root of 1 plus 1 over x dx. Now if you work this out, you're going to get x over x plus 1 over x, which is x plus 1 over x. If you square root them both and you bring this guy down, that cancels out, and you just end up with root x plus 1 for the integrand. So s equals 2 pi integral 4 to 9 x plus 1 dx. Now we want to integrate. So it's 2 pi. Now this is x plus 1 to the 1 half, so it's x plus 1 to the 3 halves times 2 thirds between 4 and 9. So it's 4 pi. I think I'm missing a 2. There was a 2 there. Yeah, y is 2, so this was this should have been 4 pi. Yeah, and I wrote 2 pi, so this should have been 4 pi. And now it's 4 pi times 2 pi over 3 is 8 pi over 3. Plug the 9 in, it's 10 to the 3 halves. Plug the 4 in, it's 5 to the 3 halves. And that's more than enough, right? Example 2, find the area of the surface that is formed by revolving the graph of y equals 9 minus x squared, where x is between 0 and 3, over the y-axis. Now, so the revolving is about the y-axis, so we go to number 2. Is it y equal f of x or x equals g of y? It's y equals f of x, so it's got to be this formula. So let's write it down. 2 pi a to b x square root of 1 plus f prime of x squared dx. So it's 2 pi integral from 0 to 3 x. If you do the derivative of 9 minus x squared, it's negative 2x. When you square it, it's 4x squared. Now we can easily integrate by doing u substitution. So u equals 1 plus 4x squared. Du is 8x dx. We have x dx. We're missing a constant. So we times by 8 and then divide by 8 on the outside. 2 pi over 8 is pi over 4. Integral 8x dx is du, and that's square root of u. And I'm leaving the limits out because u does not have the same limits. I don't want to switch them. I will switch back to the limits of x once x is back. So u to the 3 halves times 2 thirds. That cancels the 2. So pi over 6. Remember, u is 9 minus u is 1 plus 4x squared. Now we bring the limits back, which is 0 to 3. Pi over 6, we put the 3 in there, 9, 36, 37 to the 3 halves, minus 1 to the 3 halves, and that's the answer. So now let's do a couple from the book. Number 16, page 573. 16, page 573. It says, find the exact area of the surface obtained by rotating the curve about the x-axis. So we're rotating about the x-axis. What curve are they talking about? X equals 1 plus 2y squared. Y is between 1 and 2. So it's x equals g of y. So rotating about the x. So we're rotating about the axis, and x equals g of y. That's the formula. S equals 2 pi c to d y square root of 1 plus dx by dy squared dy. So 2 pi c and d, 1 to 2, dx by dy is 4y, so it's 1 plus 4y squared dy. So it's 2 pi integral from 1 to 2, 1 plus 16y squared dy. Again, we can do u substitution, where u is 1 plus 16y squared. So du is 32y dy. We have y dy, we're missing 32, so times 32 divided by 32. So 2 pi over 32 is pi over 16. And then integral of u to the 1/2 du. So pi over 16 times 2/3 u to the 3/2. Pi over 24. U is 1 plus 16y squared between 1 and 2. Pi over 24. If you put the 2, 4 times 16, 64 plus 1 is 65 to the 3/2, minus 17 to the 3/2. Okay, now one more, which I'm trying to show you as many cases as possible, like all 4 cases. 36 page 574. And this actually has an application, kind of. So a group of engineers are building a parabolic satellite dish whose shape will be formed by rotating the curve. Y equals ax squared, which is a parabola that goes through 0, 0, right? That's the vertex. About the y-axis. So rotate about the y-axis. If the dish is to have a 10-foot diameter and a maximum depth of 2 feet, so it has 10-foot diameter and maximum depth is 2 feet. Find the value of A and the surface area of the dish. So basically, the dish, so it ends somewhere, and it has to end because it's got 10 feet diameter. So this is 10 feet, so this is 5 feet. So, you know, it's symmetrical about the y-axis, and this is 2 feet. Okay, so we're taking this and rotating it about the y-axis, so we can do this part or that part. We can do 0 to 5. So it's y equals f of x, and we're rotating about the y-axis. So here we go, rotating about the y-axis, and y equals f of x, so it's this formula. So s equals 2 pi 0 to 5x. So I'm using square root of 1 plus f prime of x squared dx. Okay, thinking about the y-axis and y equals f of x. So since y equals ax squared, we can find a first. It's very easy to find a because look at this. This point is 5, 2. If we plug it in, y equals ax squared. 5 equal a times 2 squared. No, 2 equals y values equals into 5 squared. So a is 2 over 25. So y equals 2 over 25x squared. So y prime is 4 over 25x. 2 pi 0 to 5x square root of 1 plus 4 x over 25 square dx. So 2 pi 0 to 5 x square root of 1 plus 16 x squared over 625 dx. Again, using u substitution, x squared over 625 du. 16 times 2 is 32 over 625x dx. So we need to times this guy by 32 over 625, and this guy 625 with 32. That cancels out, and you get 625 pi over 16. 625 pi over 16 integral of u to the 1/2 du. 625 pi over 16 u to the 3/2 times 2/3. So you reduce 625 pi over 24. U is 1 plus 16 squared over 625 to the 3/2. Now we bring the limits back, and it's 625 over 24. 1 plus 16 over 25 to the 3/2 minus 1, which you can stop here, but if you put it in your calculator, it's roughly 90 square feet. And that's it.